Now that we've graphed linear inequalities, we're going to take a look at how to graph systems of inequalities, where we're going to graph a couple on the graph at the same time and then look to see where they overlap. So really the technique is to graph and find the overlap of the graphs. So when I look at this example here, I'm going to start with the y-intercept on this one, and I'm going to make this, remember, a solid graph. So I'm going to start with -3, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. If I went down 2, I'd have to go over a -1, down 2 over -1. And then you draw the line through those guys. And this one's going to be a solid graph because it has the or equal to. The second one, I'm going to make a dotted graph because it doesn't have the or equal to. So, well, first of all, in this first one, let's go ahead and decide which side I'm going to graph on. So because it's an inequality, I'm going to test a point. I'm going to test 0, 0. Is 0 greater than 0 minus 3? 0 greater than or equal to 0 minus 3? And the answer is 0 is greater than or equal to -3, so it's true. So I'm going to shade above it on the top half. Now, the shading on the top half will look like this. I'm going to go ahead and just mark it so that I can see that I'm going to go on that half. Now, a hint on this, if you get it into slope-intercept form for these linear inequalities, the greater than will be above, the less than will be below. But you have to make sure you get the y by itself, and you remember that if you do multiply or divide by a negative, the inequality has to flip, so you make sure you put it in the right direction. All right, I'm going to graph the second one in red here, make it dotted. So I'm going to start at 2, I'm on the y-axis for it, and then down 1 over 1, down 1 over 1, down 1 over 1. I'm going to draw this one to be a dotted graph. Okay, so dotted, make sure it's clearly dotted. And that hint I just gave you, this means it's going to be shaded below it. So I can mark it down here. Now let's just do a double check. Let's test our 0, 0 on it. Is 0 less than opposite of 0 plus 2? Is 0 less than 2? And the answer is that is a true statement. So we're going to shade on the side that 0, 0's on, and that's going to be below. Now looking at these two graphs, if I'm going above the blue, below the red, the overlap of this one is going to be just in this region right here. So we shade, make the final shading for the graph where both of them cross the overlapping of the two shading parts. Above blue, below red is this quadrant or this region of it. Let's do another example. Okay, let's start with this first one. I'm going to graph y is greater than x plus 1. So I'm going to start at 1, and this is going to be a dotted graph. So we go up 1 over 1, up 1 over 1, etc. off here. And we go down here to down 1 over a -1. And so my graph, just making it dotted, looks like that. Now the hint I just gave, we're going to graph above it. You're going to put the graph above it because it's a greater than when it's in slope-intercept form. If you wanted to test, you test 0, 0, which is below it. Is 0 greater than 0 plus 1? And 0 is not greater than 0 plus 1. So we'd shade on the other side. Let's do the next one. We'll do this one in green. So this one's also going to be dotted. Now x greater than 3, remember the graph for 3 is going to be a straight up and down line. So right here at x equals 3, I'm going to do a dotted line to show that one. Now I don't have an above or below on this one, I have a left or right. Well, it makes sense that greater than would be to the right because those would be the numbers larger than 3 for x. If you test out 0, 0, is 0 greater than 3? The answer would be no. So I'd shade on the side that 0, 0 is not on, and so I'd have it on that side. So far, I've got it above purple to the right of green, so it's going to be in this region over here, but I have one more to do. I still have to see where it overlaps with this one. So let's do this one in red. This will also be a dotted graph. It's going to be at 8, so straight across horizontal line at 8. So there's my graph. It makes sense that less than a y value will be below it. If you test 0, 0, it does work. 0 is less than 8. So I'm going to shade below this one. So using these arrows to guide me above purple, below red, and to the right of the green, it's going to give me this region right in here to shade. This little triangle is going to be where my final graph is. It's surrounded by dotted graphs, so the graphs are not included in the solution, but every other point in that region will work in all three of these inequalities. All right, so let's go back down here to example 3. Now example 3 has 3 of them to graph, just like the last one, so we have to graph each of them separately, see where they overlap. All of these will be solid graphs, just like the last one, all of them were dotted. Now, what I'm going to recommend is we think about putting these into slope-intercept form. So the way to do that is to go ahead and to subtract 2x from both sides first, greater than or equal to negative 2x minus 1. So I put the subtracted 2x first because we like x's before numbers. But notice I did not flip the inequality because subtraction or addition does not switch the inequality. Or if I multiply or divide by a positive, does not change the inequality, but now I'm going to multiply both sides by negative 1 to get rid of this negative. That does flip my inequality. It makes it a less than or equal to when I multiply everything by negative 1 to get rid of the negative in front of the y. So remember that when you're doing these, if you multiply or divide by a negative, you've got to reverse your inequality. So I'm going to go ahead and graph this inequality here. So I'm going to start at 1 on my y-axis. My slope is equal to 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, or down 2 over a negative 1, down 2 over a negative 1, down 2 over a negative 1, and draw a solid line through those points. Now, because I got it into slope-intercept form, this less than or equal to, solid because it's or equal to, the less than means I'm going to shade below it. Now, if you want to check, 0, 0 is just a little bit below it. It comes close, but it is below it. Is 0 minus 0 greater than or equal to negative 1? 0 is greater than or equal to negative 1. So I am shading on the side that that test point works. All right, let's do this next one. This one's easier to get into slope-intercept form. I just go ahead and subtract an x from both sides. So I'm going to have y is less than, put the minus x first before the number. Okay, and I'm going to shape that as a solid line starting at 4. And I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and shade or draw a solid line. And now this one is less than or equal to, so I'm going to be shading on this side of it. Notice so far I've got this region down here that will be shaded because that's where those two are going to overlap. All right, let's do the last one. This one I'm going to do a little bit differently. I can put it in slope-intercept form, but what I'm going to do is just remind you that you can graph using intercepts. One way to graph, instead of getting subtracting x, dividing everything by 4, one way to do it is to put in 0 for x. If I put in x equals 0, notice I'll get 0 plus 4y. Think about the equation, so I'm going to make it an equals. So I get 4y equal to 4, my y equals 1. So I've got an ordered pair here of 0, 1 that I can plot. Okay, so 0, 1's right there. Okay, that's the y-intercept by putting in x equals 0. Well, I could do the x-intercept by putting in y equals 0. This is why it's called graphing by intercepts. So you put in y equals 0, you get x plus 4 times 0 is equal to 4. So x is just going to equal 4 because that's equal to 0. So we're going to have the ordered pair 0, 4. I'm sorry, 4, 0. X is 4. So 4, 0. Let's go ahead and plot that point, is right there. Okay, and this is going to also be a solid line, so it's going to go straight through those 2 points. And this one, okay, I didn't put it in slope-intercept form, so I don't know, is it above or below? Let's test 0, 0. 0, 0 is below it. So testing 0, 0 is 0 plus 0 greater than or equal to 4. So when we test it, it's a false statement. So 0 plus 0, is that greater than or equal to 4? That's false. So we're going to shade on the other side. Instead of down below where 0, 0 is, we'd shade above it. So above green, we've got below purple, and below red is just this little triangle here. It's not always the triangle, just so you know, but this one worked out nicely that it's between all those graphs for the shading. All right, we're getting increasingly a little bit more difficult. Let's try the last one here, which has a quadratic in it. I'm going to first, though, do the line. So let's get it into slope-intercept form like we talked about. So I'm going to go ahead and subtract x. So subtracting doesn't reverse my inequality. Subtract x, I'm going to put it first before the number. Make sure you put the opposite with the x. The 6 is a positive, it stays positive. Now I'm going to divide everything by -3. Dividing by a negative will flip my inequality over, okay? So dividing by -3, that will make this one a negative over a negative, so it would be -1 over -3x. So remember, that's like a -1 in front. Dividing by a negative makes it a fraction. And this will be 6 divided by -3. Let's go ahead and simplify those. Negative over negative is a positive. Positive over negative will give me a subtraction. And that 6 divided by -3 is just that -2. Now let's go ahead and graph this one. So start at -2. I'm going to go up 1 over 3. 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. But when negative, I go down 1 and over 1, 2, 3. Down 1 and over 1, 2, 3. And I'm going to shade it as a dotted line because it's not or equal to. So make it dotted. And then this tells me I'm going to shade above it. It's in slope-intercept form. All right, now let's graph the parabola. Now, if you remember when we do parabolas, this -8 means it's going to move the parabola down 8 units because it's outside the square. So if you wanted to do a table on this one, you'd start your table. If you do look at your graphing calculator, you put 0, -8 right in the middle. That's where the vertex is. I'm going to start it down there, down here. And then you put in -1 and 1. And on your table, from your graphing calculator, you get that would equal -7. I'm going to plot those. And then you would do 2, -2. So put that in. Let's see, I get 4 minus 8 is -4. So 2, -4, -2, -4. And then you just keep going on the graph. So if you do more of these values, what you do is you get your graph that would go through and look like this. And it's a solid graph because it's or equal to. And now, where do I shade? Now, when you have a parabola like this or a V like an absolute value, with those, your decision is it going to be inside the parabola, which is kind of above it, or is it outside the parabola, which is essentially below it? So you have to test. If I test 0, 0, that gives me the region inside of it. And if it's false, I would do the region outside, which would be everything outside of that parabola. So let's test 0, 0. Here's my test, is 0 greater than or equal to 0 minus 8? Is 0 greater than or equal to negative 8? The answer is yes, that's true. So I'm gonna shade on the side of that. That means I'm gonna shade inside of it. Not outside would be if I had gotten a false statement for that. So what's above green and inside of this? It's going to be this area here. Let's just keep this going up here. And you don't have to, but notice that's just above the green, inside the parabola would be this region here, not this little part here for my graph. So when we're doing these systems with with inequalities, with both linears and quadratics, maybe even absolute values, you graph each of them separately. You find out where they would normally be graphed and look for the overlap of those graphs to shade your final answer.